Assalamu alaikum. I am Mohammed Sazdad. Today I am going to discuss about our recent project about on mathematics. Our title is a predictive model based on linear equation system and machine learning for crop yield production in Indonesia using the rainfall and temperature data. Here we worked together, Baby Ayuvarananda and me, Sazdad. We are from Universitas Muhammadiyah Yogyakarta. So let's begin our presentation. So let's move to the introduction. So let's first we talk about the background of our project. So while we were searching to uh, use our mathematics for solving a problem, we found out that the agriculture is a key sector in Indonesia's economy. The climate change impacts crop production with temperature and rainfall playing a major role. We got our problem statement from this background, which is traditional methods of predictive crop yields are inaccurate, and the current advanced models which are existing in related to machine learning and deep learning are very complex for the farmers using so that for using them in field level. So we got our motivation here to simplify the crop yield prediction for field level workers, and it also help farmers avoid losses and support economic growth. Our objective is to predict crop yield using linear regression based on rainfall and temperature. Let's continue. At the beginning, we started our research with some literature review to understand what things are currently existing in the world's science. So what we got is climate change is reducing crop yield in Indonesia. Then we need the need of easy to use prediction models. Then we got our regression theory, which is linear regression quantifies the relationship between variables such as rainfall, temperature, and crop yield. Then we got some information about environmental factors such as the temperature and rainfall significantly affect crop yields. Then we have drought and heat stress and cold stress impact plant growth. So let's talk about the methodology we followed during the whole process. For at first, we collected our data, historical data about Indonesia and which is its crops, such as the data sets from FAO. Then we proceeded some cleaning and handled missing values. Then we have feature selection, such as we used millimeter per year for rainfall, and then we use degree Celsius unit for temperature, and for the crop yield we use kg per hectare, hectogram per hectare. Then we have model formulation. Our predictive model is wheel is equal to a um, a constant into rainfall plus b as a constant into temperature plus c the third constant. Then our model evaluation is evaluated using MAE and R squared value to measure its accuracy and how effective it is. Then we went to the data analysis. The data summary we received is the rainfall mean is 2651.26 millimeter. The temperature mean is 26.04 degrees Celsius, and the yield mean is 83,567 hectogram per hectare. The visualization, the we use some scatter plots in our paper to show the visualization. And from the inserts, we realize that the temperature and rainfall significantly affect crop yield, and then correlation between these variables varies for different crops. Then we have model results for rice yield prediction. So for the yield prediction, we use the equation, the constants, and then where we have the equation about yield for rice prediction. Then here rainfall coefficient is 5.18. Then temperature coefficient is 13,644. And then the constant is minus 323, 323,239. So this is the related to the prediction. Then we have an example to show how effective uh, our model is. So for example, we have taken a random value from a random year where we use 100 millimeter rainfall and 22nd degree Celsius temperature. So we used our model to uh, calculate the yield. Here we can see that we also made more four predictions, more four values. So total we have five values here. And here we can see that the red line showing the predicted yield and the blue line showing the actual yield. So we can see that our linear model is quite accurately following the original actual rice yield. So from here we can say that our equation is working well especially for the rice yield. Then we have got model results, the coefficients for each crops we receive. The statistical significance is that coefficients for rainfall and temperature were statistically significant, such as P is always less than 0.05, and the predicted actual results are quite similar and shows a similar trend. So we can say that the model is very effective in terms of prediction. Here we have a last discussion. Uh, if we interpret the results, we can say that increase of rainfall boosts crop growth. Temperature also affects yield, but to lesser extent. Then we have comparison with the previous studies, such as align with earlier studies showing that rainfall increases yield. Then we had some limitations. First of all, only two environmental factors considered. For the other factors such as humidity, uh, extreme heat stress are not in the calculation of our equation. So for using our model, we may have to make sure that the other factors are in regular level or are in ideal conditions. So without those, we cannot apply this model. And then we also realized that we need more higher model for higher accuracy. We have to include more environmental factors and other factors related to the soil conditions. So to increase the accuracy, or maybe some other methods can be applied, such as deep learning algorithms, etc. So we have the scope for implications for future research, that they can, if there is any future studies about it, they can include the sunshine hours and soil conditions, so they can get more accurate data. Then, uh, in our case, we used our data from third-party organization like FAO. So we don't know how accurate these data are, how effective these data are. So if there is any chance to use field level data directly got from the field or direct surveys, those would be more reliable and more accurate compared to our current study. So let's move to the conclusion. So the summary of our findings are rainfall and temperature are significant predictors of crop yield in Indonesia. We have practical implementations that it is very simple, easy to use model for farmers and local workers. And the future works are we need further accuracy and include more factors to refine the model to increase the accuracy. So thank you so much for listening to this presentation. Hopefully, we will find some better way in the future to increase our model.